All right, welcome everyone. Let's get started immediately. So a little bit just about me, and to set the stage, my name, as Maria mentioned, is David Södlund. I title myself as a platform engineer. I live in Simrishamn, East Skåne in Sweden, together with my family. I'm interested in building stuff that really works, and I really like Kubernetes. So we're going to talk a lot about Kubernetes today. Hope that's fine with everyone. This talk is titled "What to Expect of Your IDP." So I thought we'd first manage our expectation about this webinar. We're going to cover IDPs in a nutshell. There's going to be a lot of demonstration, just showing and giving you ideas to think about, not so much through PowerPoints. I hope that after this, you leave with an optimistic view on your future developer experience. I'd really like it if you were as enthusiastic as me, but again, we're trying to manage expectations. And I like to do demos where people can jump in at any time and ask questions. So there's a chat function. I also think there's a raise hand feature that you can use, and I will see that. And if for some reason I missed your question or I mentioned that we keep it for last, we'll just take it afterwards. There might be a much in this to go through in 30, 40 minutes, but if things move too fast, just mention that actually this is too much and we'll take it slower and we'll skip the last parts. Cool. So here's sort of what I want you to think about today and to bring with you afterwards, that having an internal developer platform is really all about DevOps. It's about collaborations. It's about overcoming the gap between developers' incentive to push new features and operations incentive to keep things as they are and not break things. The most important idea in all of software engineering in order to be able to deliver working software fast is to have continuous delivery. So that's something that we're definitely going to take a look at. We want to build stuff that is cloud native, meaning it could run in the cloud, it could run anywhere, but we're not limited to any tech stack. We want to talk about desired state configuration, being able to express in code or through some other means what it is that we want and have that be reconciled for us. We want to take a look at some self-service capabilities. Sometimes we talk about X as a service. My ability as a user of a platform to request stuff and not do ticket ops, tell someone to do something for me. Instead, I'll do it for myself. I also like to think about information or software catalog as the ability to be able to Google my own organization and to find out like who's part of what team, what are they working on, be able to find technical documentation that way. So that's also something we're going to have in mind. Let's see, no one raised their hand yet. All right, let's continue on. All right, so we're going to do a short demo of something that I call a full stack app abstraction. So this is not really grounded in reality around what it actually functions as. It's more of like to give you ideas of what's possible with the tools as they exist today. We're going to run everything on Kubernetes. We're going to use something called Crossplane to make compositions, basically abstractions of different types of higher level resources. Inside this platform, there's something called the CMPG. It's a database abstraction tool for Postgres. There are some other tools to form like an ingress gateway so that we can have only authorized traffic reaching our public-facing endpoints. And then we're going to use two different visualizations tools, one of them being Backstage, which is sort of the center of all of this. And there's also a tool called Argo CD, which is a GitOps tool, just to be able to help us reconcile this desired state configuration into Kubernetes. All of this will make sense. There's some more slides also showing like how all of this functions together, but I thought we'd get started. So this is where I started from when I thought about this problem. I wrote a user story for a developer, or a developer story if you want. As a developer, I want my 12-factor app to be reachable over the internet. I want it accessible only by those people that I choose should have access, so that I can collect feedback on my app quickly. You know, another way of expressing this should not only run on my own machine. This should actually function the same way on my machine as it does in any production-grade cluster. But I want to be able to leverage those, for example, cloud resources to run my application in such a way that it's representative of a production environment and capture feedback on the app as it runs there, including like debugging and stuff. All right, so a full stack app. What are we going to do today? We're going to build some sort of front end that's going to run TypeScript and React and Vite, I guess. It seems very popular in Sweden, so I chose that. It's going to communicate to a backend that is going to run in my cluster, which is going to run .NET. The .NET backend is going to communicate with my Postgres database. And in front of all of this stuff, we're going to slap on some sort of ingress functionality. So this is what I, as a developer, imagine that I want to be able to do. And I'm going to demonstrate through my platform or my reference platform how to do this. I imagine that the way I actually go about creating something like this is very similar to how I would do like a McDonald's takeout, right? I'm going to say my application is going to have some sort of name, and then it's basically what should it consist of? Some ingress, some database. This seems like a nice abstraction. All right, let's see. Oh yeah, I'm going to cover this real quick too, I think. We might go back to this one and just show all of the interactions. There's a lot more going on behind here, but in essence, these arrows display the different interactions that we might experience here. So me, down here on the left, I'm going to log into my internal developer portal that I call Backstage, which is sort of the single pane of glass of my entire platform, allowing me to see all of the different software that my organization has. Through Backstage, I'm going to interact with some templating. And the templates will create a new repository for my full stack app. And it's also going to send to another repo that I call the GitOps repo to say the desired state of this new application is that it should be running the latest image that I've produced. And then, of course, when code changes in my new repo, it's going to update that image reference so that in the demo cluster that I have, I'm running the dev build of my app. We're going to manage all of this through GitHub Actions. We're going to produce container images, of course, because we want to run cloud native. And then we're going to have a little bit of a look at Argo CD and see how that functions. If there's time that allows for it, we're going to also look a bit at Crossplane, which is basically like running Terraform, but in Kubernetes, so that you have a control plane for it. If that sounds too advanced, don't worry about it. You don't need to know. All right, so Backstage. Backstage might look something like this. I'm going to zoom in. Is this okay for everyone? If anyone feels like they can't see what's going on, just let me know. No questions yet. Cool. Inside Backstage, there are a bunch of different functionalities that you could have. I mentioned before, it acts like a single pane of glass of my organization. So one thing I can expect to find here is that all of the software that my organization works on should be visible in here so that I can see from my business value streams what kind of systems and what components they exist of, which teams exists, what software do they own, and so on. Because that allows me then to, for example, see that inside this component, there might be some technical documentation or links or information about who operates this and where it's deployed and stuff like that. Another killer app of Backstage is, of course, the day zero stuff of being able to provision new software and have it be brought into the catalog. So that's where we're going to start. We're going to use the template that I've created here called the demo full stack template. And it's a bit more advanced than in the first slide that I showed. It's going to ask me, okay, so this new demo we're doing, this is the developers bay demo. I'm going to have to, of course, have a unique name from a new component. I do want an ingress. I do want a database. For my front end, we're going to choose React and Vite. And for my backend, let's choose .NET, like we talked about. Then there's going to be some more steps just to make sure, okay, where's this application code base going to live, right? So we're going to figure out this new repo that we're going to create. Where should that be? I've chosen github.com. That's my only one allowed right now. And it's going to be owned by my company, so that's fine. And we're going to give it a repository name. Let's put the same thing. Secondly, we're going to figure out, okay, so we want to automatically reconcile in our cluster that it runs the latest version of this. That means that somewhere we're going to keep track of this desired state, also in Git, so that we have through Git commits, we can get this sort of almost immutable state of what it is that we want. And we can also sort of go back on Git transactions forwards and backwards if we need to, if we mess up something. Oh, this arrow should go over here. So we're going to point out where that exists. This repo is called demo GitOps. I have multiple places. This one is in GitHub so that you later can see the code if you want to have a look afterwards. And then we're going to pick, okay, so we're going to build some sort of container images for the front end and for the back end. Where do we actually want this image to live? I'm not going to choose my internal stuff. I'm going to choose Docker Hub. So again, we can take a look at it afterwards. All right, so lastly, we need to tag on some metadata. This is just to make sure that if our component is part of, for example, my demo system, it is sort of grouped there. So you can think about systems in Backstage as containers for components. Where a component may be wholly owned by a single team, a system might be owned by a product owner and may consist of multiple subcomponents. And it might be useful to be able to look at components and find repos and be able to find documentation. But for some scenarios, it might be more useful to look at an entire system holistically and see what are all of the databases, for example, that this system needs. What is all of the technical documentation for this system? Stuff like that. So that's why we tag on a system. We're, of course, going to choose a team. I'm going to choose my own team here. And now comes the fun part. We're going to choose, do we want to automatically hook this new repo up to some sort of cluster as part of our continuous integration, continuous delivery? Might not want to put it in prod. So we're going to go with my demo cluster. And then there's just some metadata on how that deployment is going to happen. I'm going to skip over that. So here's sort of our order, right? So we're going through the drive-in, and this is sort of what we're going to get. We're going to get a new React Vite and .NET backend. It's going to have a database and an ingress. The repo is going to go somewhere. The images are going to go somewhere else. And this is now going to get created. Let's see, do we have any questions so far? We have one chat from Maria. All right, just Maria mentioning that you might ask questions. That's perfect. Cool. Thanks. So now we're going to initialize, and we're going to see this little view that's just basically telling us how is this template doing in terms of creating the stuff that we want. We're going to make sure that our new code exists. We're going to create the new repo. And we're going to push our GitOps configuration. And from here, we can now actually go and see our new repo. So I created it in GitHub. So here it is. It's called Developers Bay. And this is a repo that has some information on how it works. We can actually, straight away from here, if we want, we can clone this. Let's see, do I have a terminal? I do. Let's use this terminal. Cool. So we're going to clone this. And we're going to go into it. And now we can check out the README. And we can see the same information that we have on the browser. This means that we now have a copy of this. And one thing that I really like when I look at software that I built myself, it's of course nice to see that it functions the way I intended. Another more important aspect is that other people should be able to see the software that my team has created and be able to figure out how it works. And that's a harder thing, right? If we look in Backstage now, the creation of this looks like this. So it has been created. We can go to the source code here again. We can see its pipelines. Oh, it's already finished. It's already pushed my Docker image. Very nice. And when I go to the source code and I clone it, as a member of maybe another team, it might be difficult for me to figure out, okay, how does this actually work? But for example, here it says, oh, I need to run .NET. Oh, maybe I don't have .NET on my machine. Maybe I don't have Bun. But that's where containers are so useful. So I can build this Docker container, and I can actually run this on a local Kubernetes cluster with something like this. So hopefully this makes sense. This is basically a one-liner for someone who just cloned this new repo that we just created and be able to, on their own machine, run it in an environment that's very much like a production-grade environment. And this is very useful when you want to troubleshoot or you want to develop for feature sets that is only really available in like an end-to-end case. For example, like traffic splitting or maybe fault injection, retry logic, that kind of stuff. I don't want to have to roll authentication mechanisms into my .NET backend code every time. It would be nice if that's just handled by the platform. So we're going to spin this up to see what that's like. I mean, you do need some prerequisites on your machine. For example, some of the binaries that I'm using here, like CTL, PTL, and tilt, they're of course installed on my systems. You're always gonna have some prerequisites. So what it's doing now is it's spinning up that cluster. I'm just gonna see if anyone has any questions. No? All right, awesome. So this is now started. It's instructing me to, if you want to have a look at what this deployment into your new cluster looks like, you can press space. I'm going to do that. I'm going to move this over here so we can take a look. Oops. There we go. So what is this? This is basically deploying the same thing that we showed on our initial 12-factor app slide, that I have my front end, I have my back end, I have my database, and then I'm going to skip the ingress part because I'm just going to port forward. But you can see in here that it's building up all of these things from the code that gets generated. Awesome. At some point, my database is going to be up, my back end is going to be up, my front end is going to be up, and I expect that I should then be able to surf into this. So we haven't even talked about what this is yet, right? If we look at the repo, it will mention that the demo app inside this abstraction for the full stack app is just some sort of shopping list app, very simple, not written by me. I just showed my abstraction to an AI and I said, could you build something fun for a demo? And it came up with a shopping list. So let's see if it works once the layer has been pushed, or all of the Docker layers have been pushed into the cluster. 431 megabytes. That was more than expected. Okay. There we go. Okay, so it's finally up. Well, oh, the image is, okay, the container is being created. There we go. All right, so here's the developers pay app. It is a shopping list, and we can say we want to buy pizza, and we might want to buy wine as well. Cool, but I've already bought the wine. So the app works. Hooray. That's not the interesting part. The interesting part, of course, is that if we start to kill these pods, we're going to see that the database has persisted the data and so on. That's not something we're going to skip over today. If we go back to the terminal, we can open up this repo. Let's see, where is VS Code going? So far, so good. Everyone on still with me on exactly what we've done, right? We've created a new repository. We've cloned that repository, and we made sure that we can run it locally, just as we expect. And anyone who clones my repo should also be able to do this, given that they run with the prerequisites that we have. Can we preview this? No. Anyway, so the command that we actually ran was this cattle patrol apply and tilt up, and that's it. If we want to make any changes to our software, let's say, for example, that instead of like a shopping list, we want to create something else. Let's say instead we were doing a list of webinars that we want to hold for developers pay, right? We might change the app like so. I'm going to push it. Actually, I realize now that I'm not able to force push this to new repos in my organizations because of the way they're set up. So we're gonna change that real quick. Sorry. This is also something to expect when you do a demo, is that not everything works out exactly the way you want. So real quick, we're just gonna change that real quick. So we've created this new developers pay repo, and we're gonna go and real quick just change the main branch so that I can actually just push commits like a savage to save some time. Here we go. So we don't have to have pull requests with some other person in my organization then approving them, because that would take time. All right, here we go. So we changed app to now be about webinars, right? Okay, so a developer changes their app. A developer pushes their stuff to the repo. What should happen now? Let's see, where is the... are we done with this one? We don't need that. Lost my window. There we go. So we have now pushed some change set here. So I've interacted with my repo, pushed some change set. I expect it to kick off this GitHub action, push a new container image to Docker Hub, and change my GitOps repo to say that in the demo cluster, I should now run the new version of my software. Cool. If I'm a user who might not be entirely familiar with GitHub Actions and GitHub, there's a nice abstraction inside Backstage called CI/CD. This is not just a re-implementation of looking at GitHub Actions. This might make sense if your code is in multiple places, or again, you're someone who's not super familiar where GitHub Actions even is. Again, this sort of single pane of glass idea. You might have stuff that runs in Azure DevOps and GitLabs and Jenkins and some other places together with GitHub Actions. And then it would be nice to have a uniform way of seeing all of the stuff. You might also be interested in, as a product manager, you look at your entire system and see for all of the components that are part of this system, how are they doing? Is everything green or something failing? So we changed the app to be about webinars, correct? We expect to see the new version of this running somewhere. We can, of course, click the link and find this action information here. And by now, this should also be deployed to our cluster. It says progressing. That's interesting. Well, what do you expect? We can also see from this view where it is actually deployed in our demo cluster. Oh, I see what's happening. It hasn't really updated this image yet. So the front end seems to know what it's running, but the back end does not. I'm going to log into Argo CD and view this. So we, of course, have single sign-on. Oh, I'm not signed in. Let's sign in as me. I put my email in. It's going to send me to my Google account and so on. So this is my actual deployment. If you remember before, we talked about our 4 things in our abstraction. Argo CD, except for just being a sort of GitOps tool, it also allows us to have a nice UI to be able to see the things that our application consists of as they exist in Kubernetes. Oh, needs some zooming in. There we go. So we can see that our full stack app consists of a backend, a front end, something called a virtual service, which is an implementation of an ingress, and something called a cluster, which is basically a cloud native Postgres cluster, which under that, of course, has a lot of different things. So if you're interested in how all of this gets created, or you need to debug something, it's available to everyone. But for most people, they just want to see this green heart to say this app is doing fine. This app is being deployed. There's a replica set and there's some pod. And somewhere in here, it's actually running the code that we just wrote. We should expect that we should be able to surf to it, but we can't. I mean, we can access it, but since the backend is broken, it gives us a 503. But we can see, for example, that we're surfing to the web page with the address that corresponds to the app we created. And there's a certificate in front of it that's legitimate. You could surf to this web page if you want. You would have to log in through my portal, which you can't do because you don't have an account. But I can demonstrate what that might look like. So I would go here, right? And then I would, again, be brought to my identity and access management system for my sign-on, right? Once I sign in, I get to reach the different services. So let's fix that backend, I guess. Something seems to be broken. Oh, here it is. Okay. So it's run the action to set it. but it seems in the GitOps repo, something has not properly updated. So let's have a look in that repo, see if the action broke. It did. So 11 minutes ago. Oh, okay, because there's a conflict because it pushed both of them at the same time. And I'm stupid, so I didn't figure out that maybe I should do a git fetch before I try to push from 2 actions at the same time. I'll fix it later. So we can run this manually instead, I guess. So what's happening here is that, as you can see in this picture, the code that I push to my new repo, that's then updating the reference in GitOps through a workflow in that repo. But since I have 2 images and I send both at the same time, there's some sort of race condition, and then whoever is the second one figures out that I can't push because I'm not on head. So we're going to run it manually. So we're going to figure out the commit that we need to run, or we can just say latest, I guess. Actually, I'll do you one better. Let's actually go to Docker Hub and have an actual factual look at how these images look when they get pushed from our new repo here. So we have developers bay frontend and developers bay backend. In developers bay backend, there is one single tag. It was created 13 minutes ago when I created the repo. Can I copy paste this, please? Thank you. And now I'm just gonna sort of rerun this step to update that image ref in the GitOps repo so that Argo broken, right? So let's do that. Let's say run workflow. I want to fix the component called developers bay. It's the backend that's broken, and I want to set this tag. So this is exactly what got automatically run. It's just that now I'm doing it on the latest commit instead. So that's going to take a couple of seconds, maybe a minute or 2. And then this repo is going to self-update to reflect that this app is now running this image for the backend. Crystal clear so far? Cool. I should have written that I expect all of this stuff to work when I hold the demo, but I only have myself to blame. Okay, let's see. It is not done yet. Let's see how it's doing. Oh, there it is. Okay. And we can also see inside our code here that we have the latest commit here is basically saying that we updated the backend to run this image. So now if I do a manual refresh in Argo CD, because it refreshes on like a 3-minute cycle. Oh, my camera died. That's too bad. Well, you have to live without my camera for a while. Can you still hear me on the microphone, Maria?
Yes, perfectly.
All right, cool. Yeah, there seems to be an issue with my webcam. No matter, we can see now that the backend pod has been updated. We see that it runs this is very, very small, but we see that a minute ago this pod got created and it's now running with this commit hash that we wanted. Very nice. So now I expect that when I surf to it, I'm not going to have any more issues. There we go. And now it says webinars list instead of shopping list. So we're going to have a developers bay webinar. And now can I inspire to maybe have some sort of CNCF Malmö webinar? That would be nice. Maybe KubeCon 2026. I don't know. Hopefully. This is almost done. Perfect. So now we can see that I can change the code in my repo. If I'm allowed to merge it to main, it's going to lead to a new build. That build is going to push to Docker Hub. And once it's there and the proper tag has been set in my GitOps repo, it's going to reconcile into Kubernetes, and that's the code it's going to run. Very nice. All right. I think that's basically all of the stuff that I really wanted to present. If there's any questions now, we can take them. If we feel like we have more time, I can show you some more of this, but really right now I would like for people to give some feedback or have some questions that they wanted to ask, but didn't feel like they had the time for. All right.
It seems like everyone is really happy with the information they got. So as of now,
Perfect.
we don't have any questions. However, I did get a question in advance.
Okay.
That I think let's see. Who owns the IDP? I mean, which team cares for it, runs it, etc.
Okay. So that depends, of course, on your organization. Maybe traditionally, you would imagine that you have a dedicated platform team, analogous to how you would have perhaps a platform team that manages your database servers and makes sure that your backups run, stuff like that. It might be in some organizations where it's a hybrid approach where some feature team also owns part of the internal features. I like to think of it as like internal work, right? Who cares if it? Well, it's as a platform engineer, my customers are the developers that I serve, right? So if you don't have a platform team, but you still want to have a platform, well, then you have the same problem as if you want to have a very killer app, but you have no app team. If you as a developer expect to be able to have this self-service functionality, well, then you probably have to build it yourself. But that's not too bad, because one of the very good aspects of running something like Backstage and something like Kubernetes is that it's very extensible. Once you sort of get the ropes of how it functions, you can build stuff on top of it yourself. So as an example, before this demo, I've been running a lot of Azure DevOps, but now I moved to GitHub Actions. In Backstage, there is a plugin to do, generic Git clone, pull, push kind of actions from Backstage templates, but that doesn't really exist for GitHub. So I realized that other people also have this issue where we can't just deal with any Git repo the same from Backstage. So I built a plugin for that, which I hope that I'm able to open source pretty soon. And that took me a couple of hours to do. But once I have that, it can help me. But once I have this sort of platform engineering mind, it can help other people in my enterprise, in my company. Or as for my case, it can help anyone who's running Backstage and create some goodwill with everyone involved with that our company is contributing. So again, to answer the question, who should own it? Well, if you wanna empower yourself, you should choose tools which are easy to expand upon. It's not that hard to build a plugin for Backstage. It's not that hard to build an operator for Kubernetes. You're just limited by your imagination and the way you frame the internal work that you do, because it's all about reducing complexity, reducing cognitive load, except for stuff that's in your domain knowledge. I like to think about platform engineering as infrastructural work, right? As someone who needs to go from A to B, maybe someone who needs to ride a bus, you should not have to be a bus driver. You should not have to be able to put down asphalt. We can all recognize that potholes are really bad. And my role in this analogy is the person who's very interested in oil and asphalt and laying streets. But you're the person who wants to go from one place to the other. You're the one who dictates where the roads should be paved, but you should not have to be able to lay it all down yourself. So that's how I think about it. Not sure if it answered all of the questions. So Jocke has a question. Can you do some more health monitoring of the component? 200 to head throughout. Also include business logic, aka the app is up and logically working. Yes. So we did not cover all of the stuff in my platform, but for example, if we look at in our cluster, let's just make sure we're not using the developers pay app cluster. We're going to switch this to management cluster. You can actually see there that in my case, I'm using virtual services in Istio, which allows me to then, in my platform, I can build abstractions to use all of the different Istio functionality. So if I want to do, well, one thing I do in my case, for example, is I have an authorization policy so that any traffic that's not authorized gets redirected for login, right? I could probably demonstrate that at a later time. You could also imagine that you build in things like canary releases. You can, of course, automatically through the platform inject open telemetry or other instrumentation for your app. It's very trivial to, in your app, just say these are the different liveness and readiness probes and other types of endpoints. It's always a question of whether or not you want to automatically inject this or if you want to have your templates sort of build it. One thing I recommend is that if you have a stack that almost everyone uses, for example, like .NET 8 with and C#, that you build your own base layer image instead of relying on the Microsoft's .NET SDK image, so that in your image you can actually build in the instrumentation that you want in your organization and your sort of golden path of how monitoring should work. So it's, again, very extensible, not only the tools we use, but also the way we think about it. Great question, Jochen. Would be great if you told me if I answered your question or not. And yeah, all right, cool. Yeah, you can reach out afterwards. You have the QR code there that goes to my page if you want to have follow-up questions that you want to take offline, or if you think about these questions at a later time, or when you start working next week, you feel like, hey, this feels like the sort of problem that David said that I should expect to be able to get rid of. How do I actually do it? All right. I think that's all for now then.
Yes, it looks like it is. And thank you so much for this presentation. And this video will also be uploaded on Developer Space YouTube, so you can look it up afterwards if you didn't join from the start. And also reach out to David if you have any more questions. And thank you so much.
Right. Thank you. Bye.
Bye, everyone.